So there's two laws of physics that we can apply to any system and use them to determine if the system's going to be successful, however you define it. The first law is called the First Law of Thermodynamics, and it says this, that every system at any point in time has a finite amount of energy. Intuitively, this should make sense. Imagine a person stranded on a desert island. Okay? Unless they can go and get new energy from the environment, more food, more water, they're going to quickly perish, right? Same thing's true for a company. If a company isn't getting new energy, money, resources, clout in the marketplace from its customers, it's quickly going to go out of business, isn't it? So every system, no matter where you find the line, has a finite amount of energy. Okay? The second law of thermodynamics is called entropy. Basically, entropy means that shit's always falling apart. Okay? So congratulations. When you woke up this morning, you had a finite amount of energy and it's all falling apart. That's life. Here's another way to visualize entropy, right? Over time, things disintegrate. This is a very, very powerful law in physics. In fact, if you're a physicist, you'll know this. But your theory can go up against just about every law there is. Right? It can go up against the law of gravity. It'll be seen as curious. It can go up against the law of special relativity. People will give you attention. But if your law goes up against the law of entropy, all you can do is hold your head and cry because it's irrefutable. Right? You're just going to suffer. So just keep these things in mind. Success, then, however you define it, is a function of these two things. This is based on these two laws of thermodynamics. Success is a function of integration over entropy. I'm going to define both of these, and then we're going to use some examples so that it'll become really clear. Integration. What's integration? Well, we know that every system has to get new energy from the environment. When a system's integrated with its environment, that's how it gets new energy. How it gets integrated is by aligning its capabilities with opportunities. Let's take a closer look at that. Not all opportunities and capabilities are created equal. We can break them out into two distinct categories. So there's growing opportunities and shrinking opportunities. And there's unique capabilities and generic capabilities. If you want to be successful in your career, if you want to make a lot of money or have lots of options in your career, then where you want to be in your integration is right up there in the upper right. Okay, if you're up there, you're happy. Life is good. Why is life good? Well, there's a growing opportunity, which means there's lots of resources, there's lots of energy available. Okay? And at the same time, you have unique capabilities. So if we were to look at a business right now, we could put Apple up in that quadrant. Think about it. It's a growing opportunity. There's lots of available energy. There's a growing demand for mobile computing, phones, access to information and entertainment right at your fingertips. Apple has very unique capabilities, don't they? Think about it. Branding, global supply chain management, iTunes, App Store, right? They have this unique set of capabilities. They're serving a growing market opportunity, really, really good integration, really, really great potential for success. Think about this a little further. Any company that's up in that right quadrant has successfully built an ecosystem around itself. If you look at the top 10 companies in America by stock market value, so like the top 3 right now I think are Exxon, Apple, and Microsoft. All 3 of those have created an ecosystem that they control. What that means is it's very efficient for them to extract new energy from it to themselves. Apple, for example, if you buy an iPhone, you get your apps from the App Store. It's very seamless. It's very easy to engage and get new money, get new energy from you into the company. Exxon owns the entire petroleum vertical, from exploration to extraction to the gasoline station, right? They're extracting new available energy. They have a unique set of capabilities. That's how you get to be successful. Less good is, let's start here. If you're in a shrinking opportunity, right? If the available energy is going down, if the market needs are changing, if there's not that much available opportunity, but you still have unique capabilities, you can kind of make it there. let's see, a company like this might be Microsoft. Okay, still have a set of unique capabilities, but notice how they no longer really apply to today's environment. Applied to the environment in the 1980s really well, pretty well in the 1990s. They used to kick Apple's ass, right? Apple's better integrated with today's environment. So you can still make it there, it's just not nearly as much fun. The other one is if you are in a market which is really growing, but you have generic capabilities, you can make it there too, it's just not as good. So let's say healthcare, right? Healthcare, growing opportunity, big need, growing market, lots of available energy. But why do most family practitioners suffer? Right? Generic family doctor, they make enough to pay their bills, to pay the rent, to pay the overhead. Most of them are really stressed. They want more money. They want more ease in their job. They're thinking about leaving their profession. It's because it's a set of generic capabilities. From the market's perspective, there's lots of practical alternatives to a family practitioner. It's hard to set them apart. Who has the most success as a medical practitioner? If that's how you define success, would be those who have unique capabilities, right? You go to the best brain surgeon for your particular condition, or the best allergy specialist. If you're of course, this should be obvious, where you don't want to be in life for your career is with generic capabilities in a shrinking opportunity, right? That's just a recipe for suffering. So this would be like a real estate agent for the past 4 years, right? Market's tanking, not a lot of available energy, lots of real estate agents to choose from. That sucks. What do the good real estate agents do? Well, the ones who've made it have tried to position themselves with some perceived uniqueness, right? I'm the best agent in high-end Montecito homes. Or I'm the best agent for foreclosed properties in a short sale. You notice how they try to do that. It's true for every industry. In fact, all of advertising and marketing is basically just trying to position in the environment's eyes and the market's eyes about why you're unique, why you're different. Okay. So let's go back to your career. You want to find, you're here at college, by the way, whether you know it or not. You're trying to develop your capabilities. You're trying to develop capabilities and find where to apply them in the world. And you have a choice. You can apply them in shrinking opportunities or growing opportunities. It's a really interesting question, though, how to predict what's going to be a growing opportunity 5 years from now or 10 years from now. Maybe we can talk about that a little later. Okay, so that's integration. You want to get integrated with the environment because that's where the energy is. If you're not integrated, you're going to perish. The most interesting part of this formula is below the line, and it's entropy. And I'm using it as a measure of all the energy and effort that has to take place within the system in order to maintain itself, make decisions, and get the work done. Here's why this is really important, is that available energy first flows below the line to manage the system, to maintain the system, to keep entropy in check. Only after those internal needs are met do you have energy left over to do integration with the environment, integration with the outside world. So here's a person in a hospital. This is a physics problem. Okay, here's a patient. He has a finite amount of energy. All of that energy, available energy, first has to go to heal himself, right? Has to keep the entropy in check, or he'll fall apart, he'll die. He has very little energy left over to be in integration with you if you went to visit this person. That's why if you go to visit a relative in the hospital, visiting hours are kept short. Okay, that patient doesn't have a lot of extra energy available to be in integration with you. That's why a good doctor won't let their patient be pestered with tests day and night, right? They'll let them time to rest and recuperate. This is just physics. Here's another example. So I saw that Lindsay Lohan was in the news again. And this is just a physics problem, too. So it depends how you want to look at this. Imagine if you were a movie producer, right? And success for you is selling a lot of tickets. You need to find actors to fill your parts. The decision-making process you'd go through to choose would you hire Lindsay or not, you'd weigh this. Even if you don't consciously aware of it, you say, okay, here's an actor that might get a lot of attention, give me good integration, but the entropy on the set is going to be really, really high. Right? Do I make that trade-off? Okay, just recognize, though, that the available energy for the film has to go through the entropy before it can be successful above the line. That's why the insurance on this film, if you were to hire Miss Lohan, would be about $1 billion, because the odds are against you. You could also look at it from her perspective, right? What would be integration for her? I don't know, but let's say it's to be a successful actress, to have great, fulfilling parts. Well, the entropy in her mental, emotional systems is high, right? So she has less energy available to be in integration as an actress. The same thing's true for you, by the way, as a student. Okay, you have a finite amount of energy. Let's say you just had a fight with your boyfriend or girlfriend. Okay, that's a mental emotional system, has a finite amount of energy, so you have less energy available to do your homework, to be present in class. Okay, you got to somehow make peace with that, or fix it, or heal it, in order to free up the energy to be more present. Same thing if you're working 2 jobs and carrying a full course load and up really late, you're just tired. So you come to class, you're just not that engaged with the work. It's physics. You got to somehow lower the entropy needs in the system, get more rest, okay, pop a stimulant, right? Take some coffee, that's what we do. The only issue with stimulants and coffee is that just masks the symptom. It kind of gives you a temporary boost, but your internal system's still needing that energy, right? So it's a long-term cost. So we balance that as well. Imagine you're with a startup. Okay, what's a startup trying to do? A startup is trying to create a unique set of capabilities into a growing opportunity. That's it. That's why a VC, if you come with their plan, and they'll ask you this question ultimately, okay, what's the defensibility here? They're basically saying, what's unique about this that isn't perceived as a practical alternative? Okay? And what's the opportunity? But imagine you're in this startup, you've got a great opportunity, you've got a rock star software team, you're excited, but inside the company, the founders are at each other's throats, right? They want fundamentally different things. So the infighting in the company goes up really high. That's a physics problem. The company has a finite amount of energy. That available energy has to go to try to maintain the system, right? To navigate through this quagmire of destructive conflict. There's less energy available to find the opportunity to execute. So they'll miss their window. Okay? By the way, if you had an unlimited energy supply, you could take a long time to go and find and be in integration. Right? The pressure here is with the startup is it doesn't have an external funding source. If it gets an external funding source like venture capital or a parent company to fund it, that gives it that energy it needs from the external environment to try to continue to find integration.